Hey programmers, welcome to yet another video. In the last video, we have discussed about typecasting and how to convert one data type to another data type and what are the rules and regulations and all. We have discussed about some examples as well. We have seen several examples from int to float, float to int, and even from boolean to integer, and several things we have discussed. And I thought we have covered the entire typecasting. And now today we'll be discussing about the Python operators. What are the operators we are having in Python, different types of operators, and why we'll be using operators, etc. We'll be discussing for today. And also we'll be briefing about the arithmetic operators as for now for this video, and the remaining operators will be gathering in the next upcoming videos as well. So for now, let's look at operators, Python operators. Generally, we are discussing about Python operators because the operator is a symbol that performs a specific operation between two operands. If you are having two variables, let's assume you have A and B. If you want to perform a specific operation between them, you have to place an operator. Like if you want to perform an addition operation, you have to say like A plus B. If you want multiplication, A into B. If you want subtraction, it should be A minus B, right? So like that, between two specific operands, the A variable and B variable will be called as operands, but the symbol which we are placing in between of them will be called as operator. Let's assume A plus B. Here A and B are nothing but operands. A and B will be called as operands, whereas plus will be called as operator. A comma B will be called as operands, whereas plus will be called as operator. So generally we use operator for performing some kind of operations. Whatever operations we are likely to perform, we'll be using operator in between the operands, right? So operators serve as the foundation upon which logic is constructed in a program, in a particular programming language. Even in your Java or in C, you can see the operator will perform specific operations so that our logic will be building upon the logic. The construction of the program will be maintained by these operations itself. Okay. So in every programming language, some operators perform several tasks, right? Same as other languages, Python also have some operators, and these we'll be looking about them. There are arithmetic operators, comparison operators, and then assignment operators, logical operators, bitwise operators, membership operators, identity operators, and finally these are the several operations we will perform in Python, especially in Python. So these are the types of operators we have: arithmetic operators, comparison operators, assignment operators, logical operators, bitwise operators, membership operators, and identity operators. So these are the things we will be having. Generally, arithmetic operators means which performs addition, subtraction, multiplication, basic mathematical operations, right? Comparison means to compare between the relation between A and B, like whether the values are equal or not, like that it will be comparing. Assignment operators will be like assigning the values to variables, like that. Logical operators will be discussing about logical, bitwise, and membership operators as well. Membership in the sense whether the variable value is within the limits or not, or if you have a list of elements like 1 2 3 4, let's say A is equal to, we will be having in Python list 1 2 3 4 5. Let's assume whether 5 is in A or not. If you want to check 5 is in A or not, or 3 is in A or not, for that purpose you have to use membership operators, whether it is a member of that A or not. We have to check that. Identity operators, these operators we'll be discussing in the further sessions, and for now we'll be discussing about arithmetic operators, right? So in arithmetic operators we have addition, subtraction, division, multiplication, floor division, modulo division, and exponent. See, we have discussed like this, right? Addition, subtraction, division, multiplication, floor division, modulo division, and exponent. We will be discussing in depth what are the differences between division and floor division, exponent, modulo division. Okay, let's take some variables, like let's say some examples now. Let's assume a is equal to 5, b is equal to, let's take 2. If you want to perform addition operation, just simply place a plus b. If you run this, you'll get the output as 7, right? In the same way, if you want to print a minus b, you will be getting the output 3, right? In the same way, if you want to perform multiplication operator, it's as simple as this. A into b, 10, 5 to 10. Print a by b. Just look at the outputs for now. A by b, you have getting the float value of 2.5, right? In the same way, let's take floor division. We have seen the division, right? Let's see the floor division. What will be happening? What will be happening in this? Just run it. See, you got integer value of 2. If you do the floor division, you have got integer value of 2. Let's take modulo division for now. If you divide with b, what you will be getting the output? 1. See, it is as simple as this. What we are doing is, for a by b, we will be getting float values. If we divide a with b, we will be getting the float value. Like in the coefficient value you have in division, right? In the coefficient value you will be getting by dividing, right? For a by b, it will be converting the float values itself. 2.5 it will be giving. For a floor division, for the floor division, in the case of floor division, if you place the division operator like this, it will be rendered as floor division. So for floor division, it will be converted as integer type of values. The decimal places will be neglected, so the division will be stopped for that number itself. So we'll be getting the integer type of values as a result. Okay. In the same as this percentile, if you are using the modulo division, what we are doing is modulo division. What does it refers is, it gives the output as a reminder. Whatever reminder we will be getting, right, after dividing, we'll be getting some reminder 0 or 1. If it is successfully divisible by 2, we will be getting 0 as reminder. If it is not divisible, it will be getting 1. Let's take 4, we'll be getting 0. See, we have got output as 0, right? Because 4 is perfectly divisible by 2. Okay, so that's why you will be getting 0 or 1 as reminders if we do modulo division, right? Okay, this is the sort of differences between division, floor division, and modulo division. So these should be kept in mind. Let's take now exponent. Print a b. See, 16. What we are doing is 4 square. A value is 4 and b value is 2, right? The double star represent exponent, means the 4 square of 2. Okay, if you want to assume 2 square, it will be giving the output as 2 square, right? So this is the things we have to keep in mind in terms of arithmetic operators, and we have to use a library called math. We'll be discussing about that library, how to import it in this video itself. Let's look at the library, how to import it. So for importing, how to import, let me clear this. So in Python, we'll be having several libraries, right? We'll be discussing about NumPy as well. We'll be having several libraries. But in Python, the syntax for importing, what does importing means? We will be including all the things which are required from another file to current file. Okay. If you want to import those commands, what you have to do is just import. We have a keyword called import and the library name. Okay. Import math. Math is a default library, so we'll be importing math. So in math, we have two functions we have, like ceil and floor. We'll be seeing that ceil and floor. If you assume ceiling means the in the building, if you are sitting in a room, the floor is in your feet, right, under your feet, and the ceiling is in top of your head, right? if you are having 2.5 as your value, if you ask math as seal to represent the seal value of 2.5, we'll take the nearest highest whole number. For 2.5, the nearest highest whole number is 3, right? So the ceiling value of 2.5 will be 3. At the same time, the floor value will be 2. It will be taking the whole number. So that's why the ceiling value and floor value, you have to keep in mind, ceiling value is the nearest highest whole number, whereas floor value is nearest lowest whole number. So that's the difference between the seal and floor. Let's look at it in programming. For importing that math, we have to use the math to itself for using the commands within that math library, right? If you want the seal value of 5.6, if you run this, it will be, let me print this. If you are having Jupyter notebook, it will be easily showing you the output. We are using IDE, so we have to print it. So the seal value of 5.6 is 6. This in the same way, if you ask math.seal, floor 5.6. So you can see the floor value is 5, whereas the seal value is 6, right? So this is the sort of difference between seal and floor in math. Okay, this is the thing you have to keep in mind while asking the seal value and floor value. We'll be using several things in terms of conditional statements as well. If you are using in loops as well, we'll be using several things. So we have to keep in mind the seal value and floor value differences. So that's about the math library. We have several sort of functions in math library, but for now it is enough. So this is for the video. If you are liking the video, please like, share, subscribe, and if you are not subscribed to the channel, please subscribe it. Thanks for watching.